Use part one of the fundamental theorem of calculus to find the derivative of that function. See how it has f prime there? So what's that? Well, the fundamental theorem of calculus says this. If you have an integral from, let's say, a to x of some kind of function f at t dt, and then you take the derivative, the d dx of the integral. What happens is the derivative and the integral cancel each other out, and you can just plug in the x there for t, and the answer is f of x. So the point is, integrals and derivatives are opposites. Dun, dun, dun. That was the big discovery that Newton and Leibniz made in the, I can't remember, 1600s, 1700s, um, called the fundamental theorem of calculus. That was the 1600s. Might have been the 1500s. Anyway, fundamental theorem of calculus. That is, the integral and the derivative are opposites of each other. So if you take the derivative of the integral, they cancel. And you can just plug in the x. So that's what we do here. There's nothing to this. Because they're saying take the derivative of this. So if I take I'll do a prime right on that. The derivative of that, it cancels out that integral. Just plug in that x. Now the square root's still there. That's whatever the function is, all that stays in place. You just plug in x into the slot, 3 cubed. You can leave it that way or make it whatever, 27, 3 times 2 times 3. You don't have the dt because the dt is part of the integral, right? The integral and the dt, those two go together. They're saying, hey, integrate that function that's in the middle like a sandwich. Those go away because the derivative canceled the integral and his little dt piece. You can kind of see it like this and this cancel dt dx, except you plug in the x for t. So that's the answer. It's all you do. You just simply stick in an x. And so that's the fundamental theorem. Integral and derivative are opposites of each other.